Hi everyone, this is question Aisha and I'm going to take you through question 3, 4 and 5. So question 3 is, suppose Q and S are independent events such that the probability that at least one of them occurs is 13 and the probability that Q occurs but S doesn't occur is 91. What is the probability of S? So here we first define the unknowns, whereby we let probability of Q to be small q, probability of S to be small s. We apply, since they are independent events, the probability of Q and S both occurring is Q times S. The probability of Q occurring but S not occurring is Q times into 1 minus S. The probability of the union is Q plus S minus Q times S. Then we set up the equations by substitution method. Then when we use the substitution method, we get S to be out of 2 out of 9. Then at the end, the value of the unknown, which represents probability of S, is exactly 2 out of 9. So our probability of S is equal to 2 out of 9. So as we can go through the next question, question 4, a family has 5 children. Assuming that the family of a girl on each birth is 0.5 and the 5 births are independent, what is the probability that the family has at least one girl, given that they have at least one boy? So here, as you can see, the given that the number of children we have 5, probability of a girl we have 0.5. Then we get the total possible gender combinations, which is 2 power 5, which we get 32. Then we define the event. Since event A, a family has at least one girl, event B, a family has at least one boy. Then the target, our target in the question, it is this one. So we calculate the probability of at least one boy. We get it from all girls, which is 1 minus 1 out of 32. Like all girls, we get 31 out of 32. Then now we calculate the probability of at least one girl and at least one boy. Since all outcomes of boys is equal to 1, outcomes for all girls is equal to 1, then the outcomes of both, and 32 minus 1 equals 30. Then we get 30 out of 32. Then our final calculations, we are going to get 30 out of 32 divided by 31 out of 32. Then the total answer, we are going to get the probability that the family has at least one girl, given they have at least one boy, is 30 out of 31. So when I take you through the question 5, if we randomly pick 2 television sets in succession from a shipment of 240 television sets, of which 15 are defective, what is the probability that they will both be defective? We are given data. Total television sets we have 240, so defective television sets we have 15. So we get the non-defective sets equals 240 minus 15, we get 225. Then the probability that the first TV is picked is defective is 15 out of 240. But then the probability that the second TV is defective without replacement, we are going to get 14 out of 239, since it is without replacement. So the probability that they will be both defective, we are going to get the probability that the first TV picked is defective divided by the probability that the second TV is defective. Then we get the answer as 0.00366. Thank you.